The question we are solving now belongs to test series 2. It is of signals and system subject. In specific, it belongs to diversified topics or filter design. As per the question, there is a signal cos of 100 pi t which is sampled at 150 pi radians per second. It is given that the sampled signal is reconstructed using a low pass filter of cutoff frequency 75 radians per second. So here we need to find the output. This here we need to find the output signal that is obtained after low pass filtering the sampled signal. So from the given data we see that the input signal is cos 100 pi t and the frequency representation of cos 100 pi t will be as shown. We know that the frequency representation of cos 100 pi t will have a form of k multiplied by delta of omega minus 100 pi plus delta of omega plus 100 pi. From this we see that the frequency representation of cos 100 pi t will have a impulse at minus 100 pi and another impulse at plus 100 pi. But it is given that this signal is sampled at 150 pi radians per second. We know that if any signal is sampled by omega s by a frequency of omega s, they will have the frequency band separated by omega s. So from this we see that in the frequency representation of the sample signal we will have the frequency representation marked replicated at intervals of omega s. From this we can say that the frequency representation will get modified as shown. So as per the original signal there are two impulses at minus 100 pi and plus 100 pi, and there will be another band which is centered at 150 pi, and we know that as the another band is centered at 150 pi, it will have an impulse at 50 pi and another impulse at 250 pi. Similarly, on the negative side also, we will have one band or one impulse at minus 50 pi and another impulse at plus 250 pi. This is because of the centering of the band at minus 150 pi. Now it is given that this resultant signal is low pass filtered with a low pass filter of cutoff frequency 75 pi radians per second. So due to the low pass filtering, so this band will be removed and this band will be removed, or rather say these two impulses will be removed, and we will be left with two impulses, one at 50 pi, other one at minus 150 pi. So from this we can say that the resultant signal xr of t can be written as cos of 50 pi t. This is because the resultant signal is k multiplied by delta of omega minus 50 pi plus delta of omega plus 50 pi. So the reconstructed signal xr of t will be equal to cos 50 pi t. So from this we can say that the correct option representing the reconstructed signal is D.